Application of Biot-Savart law on combination of straight wire and the circular wire. Here the shape of wire is given, the current is flowing this way, and this is a semicircular portion of radius r. We have to find out magnetic field at B. Magnetic field at B. A magnetic field at O. So we have to find out magnetic field at O. See, already we have seen magnetic field due to straight wire, this straight wire at any point along its length at any point is 0. This already seen, we will see it once again also. We say this is the portion E. For portion A. Portion A, it is straight wire. So here, this is the wire, this is the end of the wire, and this is the radius r with respect to O. From here, this portion starts. From here, this portion, this is dl. Since current is flowing this way, so dl vector will be in this direction, and r vector is in this direction. So see here, r we have used because r is nothing but the length between the current element dl and the point at which we are interested to find out the magnetic field. Therefore, here instead of r square we use capital R. This portion, r vector in this direction because it is a radius. Therefore, theta, what is theta? Theta is equal to dl vector is in this direction, r vector is in this direction, theta is equal to 180 degree. And putting in this equation, sine of 180 degree is equal to 0. Therefore, the magnetic field produced by the current element, produced by this current element, not in the entire length, dB is equal to mu naught by 4 pi into I into dl into sine theta. Theta is 180 degree divided by r square. So since sine theta is equal to 0, therefore dB is equal to 0. It means this small current element produces a magnetic field of 0 at center O. It means this will also produce because this is r vector, this is dl vector. So every portion will produce 0. Therefore, we can write the magnetic field produced by portion A. Portion A is 0 because 0 means it can be written as null vector. It is a vector magnetic field. In magnitude, its magnitude is 0 and 0 has no direction. So this is the first portion. Then we will for the second portion. Second portion is a semicircular portion. Second portion is semicircular. Semicircular of radius r. Already we have seen the magnetic field produced is equal to, we can write mu naught by 2r into I into angle subtended at the center divided by 2 pi. This we have seen. What is the angle subtended by this angle subtended by the semicircle? It is here to here is 180 degree. So 180 degree means, sorry, this is 180 degree, that is pi. So 180 degree, which you can call it as pi, that is theta is equal to pi. And what about sine theta? Sine theta is equal to pi. This we can put, or we can write in place of theta, we write mu naught by 2r into I into pi by 2 pi is equal to mu naught by 4r I. This magnetic field due to B portion can be written as mu naught by 4r into I. This we can write directly, we can write this way, or we can solve it also. See, this is the circular portion. This is the circular portion part B, and this is radius. This is a dl vector. So r is equal to r. In this portion also r is equal to r, because the distance between the point O and the dl vector is r, which is equal to, here is r. And what is the angle between? This is a dl vector, this is r vector, and theta is equal to 90 degree. It means sine 90 is equal to 1. This. So now we can write this in this formula, dB. What is dB? Is equal to mu naught by 4 pi into I dl into sine 90, since sine theta is equal to 90, and divided by the distance square, and this is equal to 1, or B, due to portion B, is equal to mu naught by 4 pi, this is equal to 1, into I divided by r square into integral of dl. Why we write integral? Because integral of dB is equal to b. So it means once we integrate this side, we have to integrate this side also. This already become 1, and mu naught by 4 pi constant we have taken out. I is also constant flowing, and the radius also constant we have taken out. Only dl is left out. We write dl. What is dl? Value of dl? dl is equal to 2 pi r divided by 2. Why? Because the length of this semicircular portion, we take the circumference of the full circle on half of it. Circumference of the full circle into half of it. Or we can write this way, into half is equal to pi r. Therefore, magnetic field due to portion B is equal to mu naught by 4 pi into I divided by r into pi r. Integral dl is equal to 2 pi r, half of the, because total is 2 pi r, and half of it is equal to pi r. So this and this we cancel, so 2 pi r square. So here is this r, pi r. So therefore magnetic field due to portion B is equal to mu naught by 4, this also can be 4 r, mu naught by 4 r into I, mu naught by I by into r. What about the direction? We have to find out the direction. So this is matching with the result which already find out. Okay, mu naught I by 4r. What is the direction? The current is flowing here this way, in this direction. We put a right hand thumb rule. Right hand thumb in the direction, the thumb in the direction of current, we curl it. It means here it is, so below the portion it is entering inside, and it is coming out. It means it is entering this side and coming out that side. You have to be careful. This you see, when you see like this, thumb in the direction of current, and it is entering inside and coming out of the board above this wire, above this wire, it is entering inside, coming out. So we are interested in this portion because O is below this line. Therefore, the direction of magnetic field at B is equal to this way, that is into the plane of the board. Third portion, obviously it will come 0. Why? Because at any point, the magnetic field due to straight wire, at any point along its length, is 0. Already we have proved this result. Again we will see how it is. See, this is the semicircular portion that we are not interested. This is the r vector in this direction, and this is dl vector. Current is in this direction. It means dl vector is in the direction of current. It means r is in this direction. dl vector is in this direction and theta is equal to 0, and sine of theta is equal to sine of 0 degree is equal to 0. It means this portion, we are seeing for the third portion, that is B already we have done, and C portion is equal to 0. It means once this is become 0, dB will become 0. Therefore, magnetic field produced due to current element dl, a small portion of magnetic field produced due to the current element is equal to 0, and B due to portion C also equal to 0, because on integrating, see here, this portion is producing 0 magnetic field at O, this portion also producing 0, this, it means the entire length is producing 0 magnetism at the center O of the semicircle. We have to find out, here we are asked to find out what is the magnetic field due to this portion, due to this portion, due to this portion at this point. So we can say this BC is equal to 0, and we can write BC due to this one is equal to 0. Now, since magnetic field is a vector quantity, so we have to add it vectorially to find out the total magnetic field. So we can write total net magnetic field with the direction is equal to B1 vector plus B2 vector plus B3 vector, that is equal to 0 vector B2, that is B1 BA into BB and BC. So BB is equal to mu naught I by 4R and into the plane of the paper plus 0. So this is the vector form. Therefore, B naught is equal to mu naught I by 4R, and it is into the plane. That is, the magnetic field at this point is equal to mu naught by 4R I in magnitude, and it is into this magnetic field produced due to the entire element is into the plane of the board.